Welcome to Ask and Learn.
We have a collar attached to a rod, which is also attached to a spring. And we want to find the velocity, which we'll call VB, when the collar reaches the bottom at point B. So we're told that K, the stiffness of this spring, is 200 Newton meters, and the length of this spring when it's unstretched, we'll call that just S1.5, and of course the mass of collar, which is 3 kilograms. Since we're dealing with a spring and it's being stretched or compressed, then there has to be some sort of spring potential, and this collar will move at a certain speed, which is what we're looking for, so there's a kinetic energy involved. So we can use the conservation of energy equation. So its initial kinetic energy is 0 because the collar starts at rest. So we just have the potential initial, which is mg times ha, so the height when it's at point A, plus potential of the spring when it's at point A, so 1/2 k x a squared, so the distance of the spring when it's at point A equals the final velocity when it reaches point B, so 1/2 m VB squared plus the potential only of the spring, because when it reaches the bottom the height is 0. So the spring potential here is 1/2 k times x b squared. So this is the distance of the spring when it reaches point B. So to find xa and xb, we can draw a triangle from the diagram. So we know that the height when it's at point B is 2 meters. And we know that the x is 1.5 meters. So we can find the hypotenuse. You can call that c, and the z, and the hypotenuse here is actually the length of the spring at point B, or point A. So z is just 2 squared plus 1.5 squared square root, and z is 2.5 meters. So that means xa, the distance of the spring at point A, is that distance 2.5 z minus the length of the spring when it's uncompressed, which is given as 0.5. So that means for xa, we have 2 meters, so that's the length of the spring at point A. And now xb, the length of the spring at point B, at the bottom, we know that the distance will be 1.5, so it'll be 1.5 minus the length when it's unstretched. So for xb, we have 1 meter. So now we can plug this back into our energy equation so we can find the velocity. So we have, plugging in what we know, we have 3 times 9.8 times 2, the height at A is 2, plus 1/2 k 200 times xa, which here it's 2 squared, equals 1/2 times the mass 3 times the velocity VB squared, which is what we're looking for, plus 1/2 200 times xb, which is 1 squared. So we can clean this up a little bit. On the left side, we have 58.8 plus 400 equals 1.5 VB squared plus 100. So add up this stuff on the left and then subtract 100, and then we get VB equals 358.8 divided by that 1.5, and then take the square root to get rid of the square. So VB, the velocity the collar reaches at the bottom, is 15.5 meters per second.